Hello, everyone. This is Jinxi from MidTech. Today, my speech topic is RedCap standardization introduction and feature considerations. My presentation consists of 4 parts. Firstly, standardization overview. Next, the main features of RedCap and essential features of RedCap UE. In the end, is release 18 evolution and prospect. As we know, RedCap is one of the work items in release 17. Motivation RedCap is targeted for middle-end use case. Its capability is lower than EMBB UE and higher than LPWA, such as NBLT and LTMTC. 3 typical use cases are justified: that the variable industrial wireless sensors and video surveillance. Objective and work scope is mainly UE capacity reduction, including UE bandwidth reduction, antenna number reduction, MMO layers and modulation order reduction, etc. In addition, high-layer functionality and power saving enhancement is supported. There are some basic principles in the work item. Coexistence of RedCap UE and legacy UEs should be ensured, applicable only to standalone mode and single connectivity. Power saving and coverage enhancement work item shall be applicable to RedCap UE. For standardization status up to now, all the specification work have been completed, except that ASN.1 will be ready in June. In this figure, all types of cellular UEs are showed. We can see RedCap UE is located in the middle end section. Its capability is higher than LPWA and lower than EMBB. Is approximate as LT Cat 4. As has been introduced above, the 3 typical use cases for RedCap UE are listed in the table. So we can see that wearables and video surveillance data rate can be up to several tens of megabits per second. Industrial sensors have higher requirements for reliability and latency. In particular, end-to-end latency is several milliseconds for safety-related sensors. Device size is scenario specific. Generally, wearable and industrial sensors need a small device size. About power consumption, wearable device requires at least multiple days standby duration. Battery life of industrial sensors is needed to last a couple of years. Okay, let's have a look at the overall capability of RedCap UE. The maximum bandwidth of RedCap UE is 20 MHz for FR1 and 100 MHz for FR2. The RX number antenna is 1RX or 2RX for FR1 and 2RX for FR2. The MMO layers is 1 layer or 2 layers for FR1 and 2 layers for FR2. Modulation order 64 COM is mandatory, 256 COM is optional. For RC secret number, 12 bit is mandatory and 18 bits optional. For FDD, half duplex FDD is optional. This is the overall capability of RedCap UE. As everyone is quite familiar with EMBB, I will not go through the EMBB UE capability. Next, I'm going to introduce main features of RedCap UE. For cell access and bar, functionality is specified that allow operators to restrict RedCap UE to access network. Info frequency reselection in SIP1 indicate whether RedCap UE can compound the cell or not. Considering the performance difference between 1RX branch and 2RX branch, GNB can allow or disallow 1RX or 2RX RedCap UE to access cell separately. Early identification enable RedCap UE to be identifiable to network during initial access. MAC3 early indication is by dedicated logical ID in MAC3 MAC PDU. MAC1 early indication is by dedicated preambles or dedicated occurrence according to network's configuration. To minimize uplink resource fragmentation for EMBB UE, separate initial uplink beta P is introduced for RedCap UE. The network can choose disable frequency hopping for common PUCSH. For offloading purpose, RedCap UE can be configured in separate initial downlink beta P during random access to avoid resource congestion in initial downlink beta P shared with legacy UEs. UE capability reporting is similar as the legacy mechanism. UE-related capability should be reported to network explicitly. RedCap UE supports separate active beta P in kinetic mode. For coexistence scenario, EMBB carrier bandwidth may be 100 MHz, whereas RedCap UE beta P is only 20 MHz, may not contain CDSB. In this case, network need to configure non-self-defining SB in separate downlink beta P for UE maintaining time and frequency synchronization. Otherwise, if network does not configure NCDSB, RedCap UE has to perform RF retuning to acquire CDSB environment gap. This is the optional capability of for RedCap UE. For power saving, extended DRX cycle is introduced as an optional feature. EDR cycle can be up to 10 seconds in active mode and up to approximately 3 hours in idle mode. RF environment can be relaxed for neighboring cell for stationary UE or not at the cell edge condition. RedCap UE reuse legacy low spectral efficiency MCS and sequence table. Half duplex FDD can be supported optionally by RedCap UE. RF duplexer is removed and cost can be saved. However, half duplex may result in impact on throughput and latency, and some use cases may be limited. For paging reception, RedCap UE monitoring paging only in initial beta P associated with CDSB in idle mode. Upon access, RedCap UE will switch to the separate initial beta P to perform random access. About handover enhancement, due to the reduction of NCDSB within the active beta P, handover and measurement procedure are different from the legacy mechanism. RedCap UE is needed to support handover directly to the separate beta P associated with NCDSB in the target cell. This case is defined as intra-frequency handover. That means RedCap UE can directly sync to the NCDSB and perform reach on the separate beta P in the target cell. These are all for the main